This video is going to illustrate to you how to create an amortization schedule for an equal principal payments loan. So watch carefully, make sure you can actually construct one of these amortization schedules on your own, assuming equal principal payments. Now a separate video shows you an amortization schedule with equal total payments. In this illustration, we're going to assume the parameters of the loan are $30,000 borrowed, 6% interest rate, and term of 10 years. And we're going to put that information in a box away from the amortization schedule so that we can link the amortization schedule. By doing so, you can change the parameters and the amortization schedule will actually change. Now, this area right here is the amortization schedule. So the first thing we need to do is show 10 years. Now watch how I do that. I'll go right here and type in year 1 and then year 2. I'll leave that year 2, then I'll come back to it and I'll darken in the 2 years, and then in the bottom right hand corner where you see that little box that's slightly disconnected, you get right on that little box, the cursor changes to a crosshair, click, hold the mouse down and drag, and now I got 10 years. That's not a big deal. You could type in 10 quickly, but what if you had a 30-year mortgage with monthly payments and you wanted to type in all 360? It'd take forever. Okay, the beginning balance on the loan in the first year is always the amount borrowed because you hadn't paid any back. So I'll go right here and type equals, and I'll just click on the 30,000, hit enter, and it puts that remaining balance. Now we cannot calculate payment until we actually calculate principal, because you know payment is equal to principal plus interest. So we're going to have to calculate these two first, and then we'll add them together to get the payment. Since this is an equal principal payments loan, this principal amount is going to be constant each one of these years, and the total has got to be 30,000 because that's where you're paying back the lender his money. So right here I'm going to type equals, and I'm going to go 30,000. Now I'm going to make that an absolute reference because I do not want that to change when I pull the formula down to the other years. So doing so, I need to put dollar signs in front of the G for and the 7, in other words the column in the row. You can shortcut that by typing F4. Right, divided by the number of years, and that also needs to be an absolute reference, so I'll type the F4. Again, now remember, all the dollar signs do is freeze that cell so it never adjusts. I hit enter, there's the 3,000. Now I can grab that and pull it down through all 10 years, and I'll get the same 3,000 because I made those absolute references. It's always a good idea at the bottom of that to sum that column. So something like this equals sum, open parentheses, click on the first number, drag through the last number that I wanted to add, close parentheses, and hit return, and that number simply has to be equal to the amount borrowed. So now how do you calculate the interest? Well, the interest is a remaining balance problem. It's always equal to the interest rate times the amount of money you have yet to pay back. So in the first time period, it's simply equal to 6%. Now you know that's always going to be held constant, so I'll absolute it, times the remaining balance in the first year is that beginning balance of 30,000. That's 1,800. And now your total payment is simply equal to principal plus interest. Right? So you're going to have to write a check for 4,800. Now, what about ending balance? Well, the ending balance is the beginning balance minus the amount of principal. Don't subtract the payment. Don't make that mistake. So it's equal to 30,000 minus the principal of 3, and it's $2,000. Okay? So let's go to year 2. Well, in year 2, what's the beginning balance? Well, the beginning balance is the same thing as the ending balance the previous year. So I'll just type in equals and go click, and there's the 27,000. Now you know the interest here is going to be equal to the interest rate, F4, multiplied by the beginning balance, 1620, and then you know the payment is equal to the sum of those two numbers. Okay? So you can already see the pattern where the payment's going to decrease and the interest is going to decrease, but the principal is going to stay the same. So what's the ending balance in the second year? Well, the ending balance in the second year is simply equal to, now you could do it two ways here. You could click on the ending balance of the previous year, or you could click on the beginning balance. To keep things logical, click on the beginning balance minus a principal payment, and that'll give you the ending balance. And of course, now the next year is equal, the beginning balance is equal to the ending balance of the previous year. Your interest is going to be equal to that 6% multiplied by the beginning balance, and then your payment is going to be a sum of those two, just like before, and your ending balance is going to be equal to the beginning balance minus the principal payment. Okay? Now you can follow this all the way through to the 10th year, and it will give you at the end of the 10th year you should have an ending balance equal to zero. Now I went ahead and filled out the table for you to show you what the whole table would look like, and in terms of the payment, the principal, and the interest, and the balance at the ending and the beginning of the period. I'm going to run in real quickly and put sums in here for some totals for the payment, and I'm going to put a sum in here for the interest column. And of course, common sense, the principal and the interest total must equal to the total payment. So in this particular loan, you're going to repay a total of $39,900, with $30,000 of that being returning the lender's money, and then $9,900 is going to be rent on his money. Just a note, don't forget the shortcut that I taught you. You can always calculate this total even if you didn't know all these numbers, okay, by taking the first one plus the last one, adding them together and dividing them by 2, and then multiplying by the number of years. For example, let me just come down here and put total interest and show you a formula. It'll be equal to the first year of interest plus the second year of interest divided by 2. Okay? And then I'm going to take all of that and multiply it by 10, and there's that $9,900. A lot of times students say, well, how do you know the interest in the last year? Well, common sense. You know the ending balance at the last year has got to be zero. You also know that the principal payment every year is $3,000. So in order to get this to zero, you know you got a $3,000 loan balance at the end of the next to last year. You know that because the $3,000 in the principal payment in the last year will pay it to zero. So you could simply calculate that last year's interest by 6% of that 3,000, which is also the beginning balance of that year. So even if you didn't know all these numbers in the amortization table, you can always arithmetically compute the interest in the first year and the last year, and so then you can use that shortcut to get that 9,900. Make sure you can do that now, because I will ask you that on some of the little Moodle quizzes. It'll just give you this amount right here, these parameters, and it'll simply ask you how much total interest would be paid over the life of the loan. One of the things that you're going to be asked to do is to create an amortization schedule with equal principal payments and equal total payments. And it's going to ask you to compare the two. In other words, find out the total interest with the EPP loan and the total interest with the equal total payments loan, and it's going to ask you for the difference, because I really want you to understand when you go to borrow money that there is a difference in these two types of loan structures, and both have their advantages and disadvantages. But it's important that you can calculate this total interest with both types of loans so that you can make that comparison.